So our project is on masonry veneer drainage systems, specifically looking at how these systems manage water infiltration in construction. Our introduction, masonry veneer drainage systems, specifically weep ropes, weep vents, and through wall flashings, are integrated architectural tools that are designed to manage and direct water that inevitably penetrates these veneer masonry facades, such as brick or stone. These tools function by collecting water in a space behind the veneer and directing it out of the wall cavity, which ultimately prevents structural damage to the wall. Without proper drainage management, buildings could face costly deterioration, such as efflorescence, which is essentially white salt staining, structural rot, and freeze thaw, spalling, all of which inevitably shorten a building's life. All these systems operate on the rain screen principle, which is essentially a process of using a ventilated air gap behind the masonry facade to manage the moisture. So this gap actually allows water that has leaked behind the masonry veneer to drain while still facilitating air circulation that speeds up the drying process. Any water that penetrates the wall is caught by a concealed drainage cavity and water-resistant barrier, and then it's channeled back outside through flashing and weep systems. So, understanding how these components work together is essential for designing durable masonry walls and assemblies. So, our presentation will expand on each of these components. We're going to discuss some standards and best practices recommended by the Industry Association and the Masonry Society, um, and then pivot over to long-term performance and where future research could take us. So, beginning with types of masonry veneer wall systems, weep ropes are the most common. They're typically are they're typically made of cotton, jute, or similar absorbent fibers, and they are inserted into vertical mortar joints to create a wicking path for moisture. So they essentially work by using capillary action. Any water that makes its way behind the masonry in the cavity is going to be absorbed by these ropes and taken outside the wall, and the water will eventually evaporate. These ropes are generally a fourth of an inch to half an inch in diameter, and they're installed at spaced intervals along the base of a wall. Um, Weep ropes are mostly valued for their aesthetics because they blend in almost indistinguishably with traditional masonry. They are also inexpensive and relatively simple to install. However, they do have drawbacks, and some of those drawbacks are the fact that they can clog mortar droppings or debris, and their performance varies with climate conditions. Um, and so, because they rely on absorption rather than physical openings, they can be less reliable in these high rainfall or wind-driven rain regions.
And weave ropes are an interesting product type to investigate when it comes to manufacturers. Again, it's a rather simple product. It ultimately is just a rope. I'd say it's typically made of 100% cotton, but other than that, there's very little variation in the manufacturing. But just to list a couple of the key players, um, they do manufacture these ropes. There's companies like Seco, Phoenix Rope and Cordage, Non Rope Supply, and Titan International. Titan International. Um, and the price of these products, they do range a good bit, but it's really just because of reasons like the size or slash like diameter of the ropes, the length of the spools, and the strength of them. But just get a basic understanding of where the price sits for these. Phoenix Rope and Cordage sells their baseline product of 5/32 of an inch by 1,000 foot spool at about $75. So that's kind of where you can expect to see um, common size spool.
Perfect. And then moving on to weep vents. Weep vents are now the most common method for draining masonry veneer. So They're more effective and durable than older methods such as the weep ropes, like we discussed, and they prevent moisture buildup that can cause structural damage, as all these attempt to do. These are small rectangular or honeycomb shaped inserts that fit into open head joints and are made from polypropylene, polyethylene, or stainless steel mesh. They create a consistent opening for ventilation and drainage while blocking insects and debris. The typical dimensions that you'll see in these wheat vents are about 2 and 5/8 by 3 by 3/8 of an inch. And so typically they're set to match the standard head joint size. Wheat vents provide cross ventilation throughout the cavity, which accelerates the drying of the masonry wall system. And their dual function of drainage and airflow makes wheat vents a far more attractive and superior tool in comparison to ropes in many applications. The disadvantage of a wheat vent is that its visual appearance can be a deterrent. Vents may be more noticeable than traditional methods if they're not color matched. So.
Yeah, and because wheat vents are the far more common drainage system used, the market is a little bit more saturated with prominent manufacturers, and all of them are finding ways to differentiate themselves. And so, providing color options has been one very common way to do so. These manufacturers provide an array of colors to help these vents blend in a little bit better with the brick and mortar being used. But also, there's some manufacturers that use 100% recycled materials to manufacture these vents. These include companies like Calf Clear and Homan and Barnard. And these 100% recycled material vents are LEED certified, or they give these builders, manufacturers LEED credits when trying to build sustainable buildings. And so that's another benefit and differentiator in some of these products. But just to give you an understanding of where prices sit for these, again, there's a wide range because of the size, color, material, etc. But comparing Home and Barnard, they have a Quadra Vent standard 200 piece box. That's listed around $75, while the York stainless steel 200 piece box is listed at $240. And so that's the same amount of product, just using different materials. And you can tell that there's a huge difference just in the material to cost ratio.
And then finally pivoting to through wall flashing. A good way to think about this is so while weep ropes and vent systems are valuable since they provide the exit for the water, through wall flashing effectively controls the path. So this continuous waterproofing membrane, intercepts the moisture and water at windows, shelf angles, and foundation transitions, directing all of this water towards those carefully placed weep openings that we talked about before, rather than allowing it to migrate unpredictably throughout the wall. So, flashing is installed at the base of the walls. We'll also see it above windows, door openings, shelf angles, and roof to wall transitions, ultimately to prevent this moisture from entering the building envelope and directing it appropriately. So, common materials include stainless steel, copper laminates. EPDM, which stands for ethylene propylene diene monomer membranes, as well as rubberized asphalt sheets. Specifically, though, flashing sheets offer superior durability and longevity because of their material. However, other materials like rubber and plastic provide more flexibility and ease of installation. So typically, these flashings will see widths range from 8 to 16 inches, depending on cavity depth and wall thickness requirements. Um, One of the main disadvantages, though, is its vulnerability to installation errors. If these through-wall flashings are not continuous, if they're not properly sealed at lapse, or if they extend even beyond the veneer face with adequate drip edges, water can bypass the system entirely. So proper installation is very important to it.
Yeah, and again, one last time, just looking at manufacturers, there's a lot of crossover between weep vent manufacturers and the through wall flashing manufacturers. Prices again vary looking at the size and material of the product. But to keep things consistent, we'll look at the through wall flashing of Homan and Barnard versus York's product, like we did with the vents. The Homan and Barnard texture flash flashing, which is made of composite membrane, when breaking down the cost, um, a 4 inch wide flashing comes out to be around 37 inches or 37 cents, sorry, per foot. And then you compare that to York stainless steel flashing, which comes out to be around $1.04 per foot. So, right, just looking at the material again, the stainless steel is about 3 times more expensive than the composite membrane.
All right, and for the last portion of the presentation, we're going to be talking about drainage cavity design and best practices, and specifically how weep vents and the flashing work in complement with the drainage cavity to provide good moisture control and air circulation for the masonry veneer. So kind of what the drainage cavity is essentially a small air gap in between the masonry veneer and the actual structural wall. And basically, it's there to create a pathway for water to escape and to support airflow behind the veneer so that stuff like mold doesn't start to grow. The Masonry Society has set out some best practices for how to install a drainage cavity. They say that the absolute minimum width that your drainage cavity should be is about 1 inch, but they recommend 2 inches to reduce the most amount of blockage. There are some caveats when it comes to different types of walls. If the exterior width is a veneer wall, then the maximum can be 6 and 5/8 inches, whereas if it's a composite wall, the maximum is 4.5 inches. And it's important to remember that the wider cavities that you have, the wider drainage cavity that you have, I mean, is that you're going to need stronger wall ties in order to make sure that the wall is secured. Some other issues that can arise within the drainage cavity is going to be mortar, pieces of mortar coming in and blocking the flashing in the weep holes. The TMS recommends using mortar collection devices or drainage mats to avoid mortar droppings from clogging up the weep holes and yeah, impeding the flow of water throughout the wall. Next, it's important for the cavity to promote airflow. So the TMS recommends, but does not fully require, a top of wall vent, which improves airflow and reduces mold growth and limits efflorescence, which is really important. Next, we're going to talk about flashing and the weep system components, specifically how they integrate themselves with the drainage cavity. The role of the flashing is to intercept the moisture from inside the cavity and redirect it to the exterior through the weep hole. Like stated earlier, the flashing should be made from some sort of durable material like sheet metal, rubberized asphalt, or some other flexible material. The most important thing stated in the recommendations that we found was that it should be installed at all horizontal interruptions, including shelf angles, window heads, window sills, and foundation interfaces. Then when it comes to weep hole placements, weep holes act as the egress for the water that comes through the drainage cavity and then through the flashing, and then egresses through the weep hole. And according to the Castone Institute, weep holes should be placed directly above the flashing at every horizontal interruption, and to space them 24 inches on center to ensure the cavity is clean for unobstructed drainage.
So finally, after all that, hopefully it's clear to y'all how crucial of a role the masonry veneer drainage systems play in supporting building longevity. However, like any tool, they only work when all components function together as one complete water management system. Each tool depends on the others and must be designed and installed as a coordinated unit to prevent water damage, including efflorescence, mold, structural rot, and freeze-thaw spalling. Looking forward, though, to where future research could take this as building walls evolve with energy codes and sustainability requirements. Um, other scholars could examine the long-term performance of sustainable materials like recycled polymer vents and bio-based flashing membranes. This would be especially interesting and important to follow across different regional climates, experiencing increased extreme weather events. Of course, sustainability and sustainable practices are have been a thing and are becoming more popular, but the long-term impact and success of them is less. Um, we have less information on that, so this would be something very interesting to follow over the years. Also, carrying on this theme of where future research could go, we see a growing appetite to integrate moisture sensors and smart monitoring technology within drainage cavities for real-time performance feedback and early failure detection. So it's essentially being able to follow this shift of masonry drainage from, we'll call it a passive system, to an active one, which would allow contractors or residents like us to address moisture issues before they cause visible damage or require costly remediation could be very interesting. So just by continuing to follow uh, and polish both material and methods, the industry can continue to engineer masonry veneer systems that remain resilient, remain efficient, and remain capable of meeting the performance demands of modern construction. Thank you.